Hello my dear students, today we will be doing experiment number 5 from your physics lab notebook. This topic we had already discussed in class 8 as well, and today we will see it experimentally as well. So the experiment is about the tracing the course of different rays of light reflecting through a rectangular glass slab at the different angle of incident. So to carry out this experiment we require few things, like the first thing we require is a piece of a plain paper, and then we require a rectangular glass slab, and we need the 4 pins which will help us in tracing the path of a incident ray, the refracted ray and the emergent ray. And apart from this we also required a pencil and a scale to draw the lines correctly. So how do we begin this experiment is, we take a glass slab and then we keep it on a wooden plank, okay, in this manner, and then with the help of the pencil we draw the outline of this glass slab, so that later on it will be easy for us to draw the glass slab accurately. Okay, so even if the glass slab is displaced, we can remove or we can replace it exactly back into the same place. So now to draw the incident ray, we draw incident ray, okay, in the given figure we draw the incident ray taking any angle randomly, okay, and this is the normal at the angle of 90 degree. So we are here to trace the refracted ray and the emergent ray. So we'll do that with the help of these pins. So we again replace the glass slab, and then we keep these 2 pins in the incident rays, one at the junction, okay, and then the other at a far place, and then we keep the glass slab back to its original place. So now to see the refracted rays and the emergent ray, we need to view it from this side of the rectangular glass slab. So I'll try to show you. So this pin you can see it through the glass slab. So do you see there? So there is the first pin and there is the second one. Okay, the second one is quite blurred. So you have to place 2 more pins in such a way that all the 4 pins here, they may be in a same straight line. So now you have to view it at this angle so that the 2 pins comes into the same straight line. So where? Yes, now it's straight. Okay, so if I do like this, you can see 2 pins from the glass slab, but if I keep it here, now you can see only 1 pin. Okay, so if you go 2, so I'll keep the 3rd pin also in the same straight line with the 2 rest of the pins. So it should be, so I keep it here. Okay, so they are in the same straight line. So is it okay? Yes. Now I will place 1 more pin such that all the 4 pins will be in the same straight line. So do you see? So if I place it here, all the pins now appear to be in the same straight line, not through the above, not from above the glass slab, okay, through inside the glass slab. See, so all the 4 pins, so the 1st, 2nd, 3rd and the 4th, so I have placed it in the same straight line. So once you do this step, now you can remove the glass slab, and then you can also remove the pins. Okay, so once you remove the pin, draw the line where the 2 pins were inserted in the wood. So the first pin is here and the second is here. So I join these 2 dots. Okay, and then you may remove the first 2 pins as well. And then suppose AB is the incident ray, BC will be the refracted ray. So here comes the ray BC. Okay, so you see that the AB and BC, they are not in the straight line. That means the ray of light, it has now bent towards the normal. Okay, so C and finally the D. So AB is the incident ray, BC is the refracted ray, and CD is the emergent ray. So here also you can draw a normal. Okay, so now we see that these are not in the straight line. See here. But if you keep the scale along the incident ray and if you extend it straight forward, okay, So if you do this, you will see that the emergent ray and the incident ray, when produced forward, they are parallel. So you see that the distance remains the same, so which is known as a lateral displacement. Okay, so this was the experiment. I'll provide you the data which I have already found, and then you will write this experiment number 5 in your lab.